sun where I am right now, and I cannot see my screen if it's black. I know that most people prefer the black background, but I have to change this morning. So, intercanister calls. The first part will be about why do we need it, and then how to do it, and we'll see calling our own canisters and calling the canister of another project. So the first thing is, why do we need it? And so for that, I will create a source folder. Inside my source folder, I will have my canister 1, and I'll have a second folder, my canister 2. Each canister is going to have its main.motoko file. So main.motoko, main.motoko. And each of them will be actor indeed. So why do we need to call other canisters? Well, there are two main reasons for that. Let's say three main reasons. The first one is that most applications built on the IC, so the applications that we use and the bigger projects, they necessarily have multiple canisters. Why? Because a canister is limited in terms of how many requests it can process per second. So, for example, a canister would be limited in terms of how much update calls can go through in 1 second and 1 round. It would be limited in terms of memory. So just this yesterday or like 2 days ago, Definity announced that the memory of the canisters would be increased to 400 gigabytes. So one canister has 400 gigabytes of memory. This is very, very big. It's great for a smart contract, but it's still limited. So if you have more than 400 gigabytes to store, you would need to have multiple canisters and store that into multiple canisters. Also, just in terms of accessibility, sometimes you want to have multiple canisters for different purposes. So for example, you want to have one for a token and another one for another token and another one for a DeFi application. So we are always working with multiple canisters, and it's really up to developers to make their own choices. We can take a look at the dashboard. So can take a look at the dashboard here. And there are right now almost 400,000 canisters deployed on the IC. And so some developers are going to go all in and do everything they need into one canister. Others are going to use multiple canisters. For example, OpenChat, they use one canister per user. I think Mora is another application. It's a blogging application. They also use one canister per user. But essentially, we are going to have multiple canisters. And that's why we have this concept of intercanister calls. This is because when we code and when we build our applications, sometimes we need information that is outside of our canister. So essentially we need information that is stored in other canisters, or we need to call functions of other canisters. So for example, we need to call a transfer method of a token canister. We need to do that, and we need to call the canister that corresponds to this token. We could also send a message to the canister of another application to build interoperability between applications. So for example, you are doing something on OpenChat and it changed something on your Discover profile. So all those sorts of functionalities, they require intercanister call generally. So it's fairly easy to call other canisters. It's a very well integrated part of the IC. It's almost like calling a function of your canister, but of course it's going to be asynchronous. So the communication between two canister is always going to be asynchronous. That's why you will see a sync await. But other than that, it's fairly easy. So let me show you. For today, we have two canisters. The first one is going to be a simple canister that stores a message. And the idea is that we need this message in our other canister. So this is canister one. Let's say canister one has a main file that is located inside source canister one and main.motoko. And canister two source canister two main.motoko. This canister is storing a secret, and this canister 2, is going to store invoices. One second, I need to close the window. Okay, I am back. And this canister is going to store invoices. So we will actually use a buffer to store our invoices. So buffer.buffer, and an invoice is going to have an ID and a status, which is going to be, well, it's going to have a field paid. If it's paid, it's going to be true. If it's false, it's going to be not paid. Then we will store our invoice in the buffer. And this canister is going to have an interface where we can create an invoice. So this will return the invoice and it will store it in the buffer. So let's new invoices.size. So we get the size of the buffer. Oops, that's not what I wanted to do. The ID is going to be invoices.size, and paid is going to be false by default, of course. And then we add that to the buffer, and then we return the new invoice as well. We have, let's use results.results. So we have a function to pay our invoice. So this is completely, of course, we don't really pay anything, but this is just for the example. And to pay, we just specify the ID we want to pay, and then we can look at the invoice to see if it's here. So for that, I will use the buffer, one of the buffer method. So I'll use this one, get optional, which return the elements at the index. Of course, the optional element, because if we call an ID that is not here, then we return something that is null. So it's invoices.get optional ID. If there is not an invoice that corresponds to our ID, we can return an error. No invoice. Yeah, that's correct. So just need to correct that, convert that to a text. So not to text is a useful method. And we need to import not. And if we have an invoice, then let new invoice is going to be ID invoice.id, and paid is going to be true. Well, actually, we can also check if invoice.paid is already true. We can say that we can throw an error and we can say invoice is already paid. Otherwise, we pay it. So when I say we pay it, we don't really send any token. We just call the method and we say our invoice is paid. Oops. Like this. And then we can use invoice.set. So this time, yeah, we need to use .put. Put, we can specify the index and the element. So this is invoice.put. And then we can return OK. So why are we doing this? I just wanted to have some functionalities for the canister too. But the main functionality that we want is to get this secret message. So this is like a secret message. You could imagine it's a valuable information. And so because it's valuable, we need to pay for it. And that's why we have this concept of invoice. But the information is not stored in this canister. This canister is only used for creating and storing invoices. So when we want to get the password or get the password, we need to specify an ID. So an ID of an invoice that has been paid. And if it has been paid, we can get the information. So let's say, so we are going to use the result.result again. Okay, so this is a good start. So we specify an ID for an invoice and we check if the invoice exists. So if it doesn't exist, we return an error. If it exists and it's paid, okay, that's the case where we want to get the password, the message, get the secret message. Otherwise, we specify return error. You need to pay your invoice first. So this is where things get interesting. This is where we want to get the message. And so when we want to do that, we need to call our canister one. So let's do it. When we want to call another canister, the first thing to do is to define a variable that actually corresponds to this canister. So a variable could be, it could be a variable, it could be a function, it could be a class, it could be a module, and it could also be another canister. And so let canister one, we need to specify the type of this variable, and it's going to be an actor. So this is where it starts to make sense, because of course we are using actor here. So this is actually just an object of type actor. So this is an actor, and then we need to specify the methods of the method of this actor. And so the method of this actor is a query function get message. And so we can take a look at it. So at the function signature, we have no argument and we return a text. And so yeah, it's going to be get message shared query, no arguments, and then asynchronous text. So it's a little bit different from what we are used. This syntax, it's very similar to what we have, when we are doing the project. So every day you have your project, and at the end of every project, you have this interface, which is defined like this. And you have this syntax where you have the function name, then you have the type of the function. And so that's essentially what I'm doing here. This is the syntax that you should use. So of course, we could have more methods. Maybe we have a function set message. Yep, so that's correct. So the function set message, yeah, we need to make it a variable here. So we could have another method. We would define it like this: set message shared new message of type text. Okay. And then we need to, so this is just specifying the type, and then we need to give it a value, of course. And the value that you give it is just going to be actor. And then here you need to specify the canister ID of your canister. So right now we don't have access to this information, so we can leave it empty like this, because we don't have access to the canister ID of canister one. So we actually need that information to be able to code it. Okay, so let's just forget 2 minutes about that. We'll get that information later and continue our code. So to get the message, we would do let message is equal await canister one dot get message. So this would be a text, and then we can return okay, and we should change the type here because we want to put the message inside here. And that's how we would get the, maybe we can call it get secrets. Makes more sense, I think. Okay. So we can deploy canister one because we actually need to deploy it first to get the canister ID. So we have the canister ID here, and we can put that inside here. And now we can compile. Now we can compile and deploy canister 2. So why do we need this await? Because remember that this is a function of type async. So if we don't have the await, this is not going to be a text, it's going to be asynchronous text. So we need to await on something that is async to actually get the value. Because this is not, when you execute your code, line by line, every line is executed at the same time. So it's just executing the code immediately, I would say. When something is asynchronous, it doesn't work that way because you are not able to call this method directly. So you need to wait. That's why you have this await. It's the whole asynchronous concept, asynchronous programming. If you are not familiar with it, it's like a concept that is across multiple programming languages. The thing is that why do we have this await? Because we don't want to block the execution of the code when we wait for this answer. So this is going to take some time, maybe like 1 to 2 seconds. And we don't want to block our canister because we want our canister to be able to answer other call, assuming that other users or other canisters are going to call some of our methods. We don't want to make this function block the canister. So when you have this await, essentially other canisters would be able to call your canister. And then when you receive the message when you receive the answer of canister 1, you resume the execution of the code and you continue to line by line. So let's try it out. If we go to canister 1 and canister 2, so this is canister 1 and this is canister 2. If we try to get the secret, oh, okay. Yeah, well, let's say with ID 0. Of course, there is no invoice, so we need to create one. Now we can check the secret. It should be, you need to pay, so we can pay the invoice. Now it's paid. And so we can get the secret. And we get the secret. So we have this information returned to us from canister 2. But remember that this message was actually originally from the canister 1. So we have successfully done our first intercanister call, and just to receive this value. So this is essentially the way to do it when you have a canister that you know the interface and you know the canister ID. You just need to define it in your code like this. So it's importing by referencing. You're referencing the canister. The good thing is that you only need to specify the interface that you are interested in calling. So for example, here we have two methods, get message and set message, but I'm actually not interested by set message. I don't use it anywhere in the code. I only use get message. And if that's the case, you can actually remove and just specify the interface that you are interested in calling. Of course, it would be also the case if I had like 20 methods here and I'm only interested in calling one, then I only need to specify one here. So as you can see, we can deploy. And we should still be able to use our canister. So can create an invoice, pay it. Wait. and it still works. So that's great. Why is get secret an update function and not a query? That's a really good question, because if you try to make it a query, you will notice an issue. So misplace await, send capability required but not available, cannot call a shared function from a query function. Unfortunately, a query function is not able to call other canisters. There is a concept of composite queries, which is a pretty advanced concept. So it's not something I'm going to touch on, but essentially with composite queries, you are able to call other composite queries. So it would be useful if you have information scattered across multiple canisters. But otherwise, a query cannot call another canister, because when you call another canister, you are actually creating a message, and it's something that requires to go through consensus. So query function, query function, they don't go through consensus, and so that's why they are very, very fast. But the downside is that you cannot call other canisters, and you cannot use an await inside a query. So that's why we need to make it an update, even though we don't change anything, we just read. But since we have an intercanister call, we need to remove the query. So yeah. Can it be done for private functions? So yes, you could have a private function that is asynchronous. Private function, let's say, gets password, get secret. Asynchronous, and it returns a text. You can totally do this. So return await canister1.getMessage. So this is a private function, and it's asynchronous. Private function can be synchronous or asynchronous. It's the same. So yeah. And actually, I could use that like, yeah, I could use that like this. Can I have a look at the create invoice again? Yes. So create invoice is simply creating an invoice with the ID that corresponds to the size of the buffer. So we just choosing an ID that way. That's pretty straightforward. And then we've set the paid field to false originally, and then we add it to the invoice, and then we return this invoice to the user. Will update functions be made faster at some point? So probably yes, but there are some limitations. So they can be made faster depending on how the subnet, so the underlying subnet that hosts the canister, is composed. So how much nodes are inside, how far those nodes are from each other, how well the connection and the network is running, how powerful those nodes are. So there are a lot of, little performance improvements that can be made. There is a limit, which would be at around 1 second, which corresponds to the limit of the consensus of the IC. So you need, every time you have an update call, you need to go through consensus. And so there is a limit which actually corresponds to the number of trips, like how much time the information should be sent between different nodes, and the speed of light. So how fast can the information be transmitted across the nodes? And it's around 1 second. So except if there is like a major breakthrough in physics and we figure out how to send information faster than the speed of light, or we change completely the consensus of the IC, then there will be a limit to how fast update call can be processed. But there are quite a few workarounds. Like, for example, 2 seconds for most application is enough. As long as the user doesn't feel the delay, you can build like a front end that's essentially, it's called optimistic updates. So when you send a message, you don't necessarily wait for the update code to be completed to send a confirmation to your user. You can optimistically change the interface, and the user, if there is an issue, you can send it to the user, but otherwise in like 99% of the cases, it's going to be fine. And also you can batch transactions. That's something, for example, for the ledgers. So there was some limitation around how many update calls can be processed per second. And so some tokens were so popular that they run into issues where you had so much update calls per second corresponding to transactions like transfer of tokens that it was slowing down. And you can fix that by batching transactions. So instead of having one update call corresponding to one action, like one transfer action, you just batch transfer together. Like you can batch 1,000 transfers together, and 1,000 transfer corresponds to one update call, and you can process much, much more transactions. So yeah, I think it's going to boils down to a mix of like tricks and improvements on the IC side. And maybe in 2030 we have like quantum singularity, and we have like a like a super fast IC. But I think for the moment it's fast enough for most applications. Like I don't think the problem it's a major problem. It's more like yeah. So that's what I wanted to talk about for the first part. So we have called our own canister, and that's great. Now we want to call the canister of another project. So how do we do that? Here in this situation, it's great. We have access to the code of our other canister, so we know exactly the interface and how it works and everything. But what happens if you want to call a canister and you're not the owner of this canister? You can do something cool, which is to go on the dashboard and try to look at the interface. So it's not the case for all canisters, but most canisters, they have their interface available. So let me show you what I mean by that. This is the canister ID. So I'm copying it. This one is the canister ID of the ICP ledger canister. So it's actually where the ICP token is stored. And this is a normal canister with a normal interface. And we can actually see this interface. So it's following the ICRC1 standard. And we can actually call this canister. So we can check the fee, for example. So the fee is 10,000. We can check metadata. So we have some information, of course, the name of the token. So ICP. the total supply, so we can check that, and that's the total supply. And we have a few more methods, so all of them here that you can see. And when you go to the dashboard, you have this section at the bottom, canister interface, which gives you a candid interface. So this is candid. You have the interface of the canister. So you have all the types that are used in the canister that are defined, all the public type. So we have quite a few here. And then at the end of this interface, which is going to be here, yeah, here you have this service object, which is essentially the interface of the canister. So you can see all the methods are listed here, and we have the types of those methods. So we could use that to essentially fill out our interface just as we did here. We could fill out here. And so we have that in Candid, but we also have that in Motoko. So we would probably use the Motoko version, of course, because we would need to use that if we wanted to call the ICP token ledger. We would need to copy that and paste that here. Of course, we would need to import each type that we use, so that would be pretty long, but we could do it. And of course, we have the canister ID, so we should be able to call it. So let's do maybe a test. Let's say we want to call the symbol method. So symbol is here. Now let's rename that. So, oops. Actually, no, I'm just going to leave that. So let ICP, ICP canister. So let's say like this. We are only going to try this method symbol. Of course, you could, try any method that you like, and you could try to do like transfers, or you could try to do that, but I want to use a simple method. So the symbol method, and I'm going to put the canister ID. So this one. And we need to import the symbol type. So I'm not sure where it's located exactly, but let's find it. Okay, symbol, yeah. So it's just a type, just a simple object. And that's good. So now we can try something. Public function get symbol ICP, return a text. And that's correct. We await on ICP canister dot symbol, and then we should receive this object, and we do dot symbol, and we return that. So now, if I try to deploy that on my local replica, you will notice something is not working correctly. If I do defix canister call canister2 and then get symbol ICP, the replica return an error, reject message canister. So this is the canister ID, not found. And this is because I am trying to call a canister that is on the mainnet, so on the ICP network, from my replica. So of course, it's not located. And that's why I need to deploy canister2 on the IC. So I will use the playgrounds just because I don't want to pay for a new canister. You could also deploy to the IC, of course. But since the playground is part of the IC, we can use it as a trick. And from the playground, we should be able to call canisters that are not in the playground. I'm pretty sure of that. So yeah, let's try it. So now we need to add the playground flag and then canister 2 get symbol ICP. Okay, so it's saying that it has no method called symbol. So maybe I was wrong. Well, it seems to be here. Okay. Not sure what's happening. So ah, mm, that's strange. Oh, I don't think I. Oh, okay, yeah, I know what's happening. So I copied the controller, which is a canister, but I don't want to copy the controller. I want to copy the canister ID itself. And if you're asking for why the ICP ledger as a controller, so the ICP ledger is actually controlled by the, I think this one is like the governance or the root canister. So it's controlled by another canister. This is to make it possible to upgrade it. But of course, it's not controlled by someone. It's not controlled by one person. That would be kind of problematic for a token. So, yeah, this is the one. So this is the correct ID now. And that's correct. So the symbol of ICP is ICP. Well, that's not a huge discovery, but at least we know that our piece of code here works. So that's great. And that's how you can call an external canister. So you can go to the dashboard, use the dashboard as a resource, copy the canister ID. So of course you need to know the canister ID, and then you should have access to the interface. You should note that unfortunately, not all canisters expose their interface. Yeah, response took a while. This is probably because the playground is not the same subnet as the ledger canister. So yeah, we can talk about that intercanister call duration and delay. So yeah, just keep in mind that not necessarily all canisters are going to expose their interface. So if you have a problem, you probably need to reach out to the developers of whatever canister you're trying to call and ask them for their interface to make them public. All Motoko canisters are exposing their interface by default, which is great. But not all other canisters. This is because like in Rust, for example, you need to manually build the candid UI, the candid file, which corresponds to the interface. Whereas in Motoko, it's automatically generated for you. So I'm going to answer a few questions. Is it, so let's say, yeah. Well, let's talk about how fast all of this is. So first thing first, if your canister that you're trying to call is located in the same subnet as your your own canister, it's gonna be much faster than trying to call a canister that is in other subnet. Why? Because of the way the consensus works. So if you're trying to call a canister in another subnet, you need to go through one round of consensus, and that will take more time, of course. If you're in the same subnet, it actually depends. It can be very fast. It can be also a little less fast if your canister is really occupied. Depends on it, but usually you can say intercanister call will add like 2 to 3 seconds of delay to your function. So it's important to not have like so many intercanister call chained in your code. Otherwise, if you try to do a lot, it's going to be, very, very slow at some point. The way to work around that is to be smart about it. So, for example, if you have like a common scenario that we would have would be you have one canister that is your token and another canister that is your archive canister. So, for example, for the ICRC1 standard, you have all transactions are recorded and they are stored in archive canister. But the kind of naive way and slow way to go about it would be every time we do a transfer, we store the transaction in the archive and we wait for the archive to confirm that it has recorded the transaction, and then we process the transaction and so on. That would be super slow. So what we do is we store around 1,000 transactions in the canister, the token, and then whenever we are reaching this 1,000 transaction limit, we send all the 1,000 transaction in one call to the other canister. So that takes just 2 or 3 seconds to store 1,000 transaction in another canister. So essentially, it's like batching transaction in one big batch, and that makes the system much faster. How did you get to that page? Well, I get to the ICP dashboard. So it's dashboard.internetcomputer.org. Is it safe to store secrets on IC? So not like this. By default, this is visible. So it's not visible by users. Like it's not like when you have a smart contract on Ethereum and this is going to be visible by everyone else. This is not visible by users, but it's in theory, it is visible by the nodes that host this canister because they have access in theory, even if they shouldn't do it. They could take a look at your code. And if it's plain text like this, and you're storing like a Bitcoin key or you're storing like a password, it's not safe. There are a few ways to work around that. Well, first thing first, you could encrypt that, but that would require some work on your side as a developer. And there is something pretty cool that is coming. It's called Vetkey, and Vetkey on the IC is coming pretty soon. It means verifiable encrypted threshold keys. So that's pretty long name, but it's very, very cool. It's a new cryptographic primitive, which will essentially enable canisters to store secrets at the protocol level. So as a developer, you can directly use that. So it's explained here how it works. So this is more like the low level. Yeah, this is more like high level. So this is coming like in the next few months, and it will be useful for encryption and like private messaging application, private social media application, also group encryption. So that would be super interesting for like DAOs, for example, because DAOs will be able to use that to store information that could only be decrypted by a certain group of people. Um, I mean, there are a lot of ideas in this article, and there are a lot of resource, even though it's still in test. It's not outside yet. But that's going to enable true privacy application on the IC. So right now we are in the like it's kind of not safe, but at some point, if you use Vedkey, it should be fairly safe to store secrets. Yeah, Vedkey can definitely help with information privacy. Am I right in thinking that something like intercanister calls doesn't exist in other programming languages outside of libraries? Well, yeah, the concept of intercanister calls doesn't really exist in other systems because it's really like specific to the IC. Um, what could be similar is like it's kind of like concept of a thread calling another thread, or a smart contract on Ethereum calling another smart contract, even though it's a different pattern of communication. I'm or like microservices calling each other. That's like kind of similar, but there is nothing exactly like intercanister call. Yeah. Can Vedkey so what's the DApp use of calling canisters together? Um for example, on the Motoko Bootcamp dashboard, when you submit your project, I am able to call your canister and kind of, test your interface by checking some functions and trying a few things. So this is one use case. Another use case would be an application that integrates with a token. You have a token, you are able to call the token directly from the application. An NFT marketplace would use intercanister calls. All sorts of application would use intercanister calls. One can use vet keys for access control. For access control, not really. That's not what I would use. Access control, you can use the principal concept, as we've seen yesterday. So you can build like an admin library or something like this. Um, you know, um, like I can show quickly. Uh, so, like this, for example. So for yeah, for access control, you can build like a custom access control system. That's what I've done. I have this concept of admins, and so I have this method where I can add admins, so they are referenced by principal, and um, yeah, and that's how I do it. And then I have this assert condition, which essentially check if the person coding my function is an admin. If it's not an admin, then it essentially traps here, so it's exiting the message. So it's not like those lines are not executed. And you can do the same, like remove admin. Uh, and like every time I want to block a function to make it, yeah, so this function is only for admin, then I have this line of code here that blocks it. Same from here. All sorts of things. Yeah. Okay, so last question. ICP's NFTs are the only NFTs stored on chain. ICP have lowest gas. Yeah, so the NFTs on IC, what are the benefits of using ICP for your NFTs? You have on-chain storage, so you can store images directly in the code, which enables you to do like dynamic collections. Collections that's where the image and the actual NFT that you see actually changes depending on actions that are done or like depending on the current price of an asset. You can do things like pretty cool. I think it's kind of underused because you have the actual image that is stored on your smart contract, like on the NFT itself. And of course, yeah, you have all the fees. Of course, the fees are going to be very, very cheap compared to other chains. So that's a major like improvement. Okay, so that concludes this session. Next session in 5 minutes. I'll just take a quick break and we are talking about errors in Motoko. So we'll talk about trap. I've mentioned trap a few times, but we haven't properly explained what it is. And we also talk about asynchronous errors and all sorts of topics. Okay, see you in 5 minutes.